Okay, so what we're going to be doing is covering Git and GitHub, and hopefully demystifying what the two are, how they're different, and how they work together. And so as before, I'm not sure if these links are also broken. That seems to maybe be working. Oh, no. Okay, so these links are broken. But on the homepage, those links are working. So you can download the course content there, and you can navigate to our course, and you can have access to all the slides and the exercises locally. So here, everything will be relative to each other. That said, for this course, I don't think you'll have to read anything in, any data files or anything like that. So it's less important. Okay, so what is Git? So as you work on a project, you collect code, you're always making these updates. Maybe you have these nice R markdown documents for your analyses that you've been making now. And it becomes tough to keep track of which version you're working with. Maybe you've built a pipeline to do some piece of analysis for you. And keeping track of which version, which is the current up to date, like a common thing you'll see in people's directories is version 1, version 2, or new and new and new, as appended to all these file names. And then it becomes just a labyrinth trying to figure out which is which. And so hopefully Git helps you both organize some of these, have a regimented system with which they're utilized and the history is maintained. And it also helps you stay in like lockstep with your collaborators. So say in a lab, you work on, you use the same pipeline to analyze some data, but you want to make an update. When you update it on GitHub or update it in Git and then share that through some a resource like GitHub, then everyone can be updated at the same time. So what is Git? It's the idea is it's decentralized, so the whole team can have a copy. It's collaborative, so the whole team can make modifications, and it has version control. So you have snapshots over time, and it's organized into this historical file manager. So you'll still have one file for a script, but it remembers what that file looked like 6 months ago. It remembers what that file looked like 3 edits ago. And it keeps that history logged. It knows who did the changes, when they did them, and hopefully, if it's correctly been annotated, why they did them. So when was Git created? It was created by this guy called Linus Torvalds, and he's actually one of the main developers behind Linux. And so he's obviously a pretty smart guy. And he was having issues with the version control system they use, so they designed a new one from the ground up with a specific set of principles. And so they went for speed, simplicity. They wanted to be able to branch. And so this means we'll go into branching a little bit later on, but you can have one branch that you're working on actively and another branch where you're maybe developing a new function. And then another branch where you're developing another new function. And eventually you maybe want to bring all these branches together to reunify on a single, the single file. Again, it's decentralized. So that means it could be shared via remote systems. And it needs to be capable of handling very large projects. So maybe you have lots and lots of files and it still needs to be able to track those. And so that can be, if you imagine, quite tough computationally for it to track and to save all these changes over time. And so what we're going to cover with Git is how to set up your own repositories that are for Git and how to keep them updated both locally on your computer and remotely on places like GitHub. And then we'll also show you some good workflows for developing your code, and then also how to use those workflows when you're collaborating with others. And so we're going to be talking about Git, which is the version control system itself. and then GitHub, which is the repository hosting service. So Git is really the mechanics of this all. It is the thing that's doing the version control, and GitHub is like an online resource which can host this and allow you to share it with other people. So they are functionally different, but they work hand in hand. And so you can use Git in a couple of different ways, and I'm going to show you both main ways on the command line and also with a GUI. Okay, and we're going to show you two GUIs, just touch on how they work just a little bit, and really I'm going to end up recommending that you use RStudio, because then everything's in one place and it's nice and easy. What we won't cover is making packages. Like, a lot of people think about packages when they think about Git and GitHub, because people host their packages on GitHub. That's a whole different kettle of fish, but it's a useful skill that you can learn from online resources as well. And there are other alternative systems. Oh, oops. Sorry, I'm just trying to let someone in. There are alternative systems. You may have heard of CVS or SVS. These are alternatives to Git. We won't talk about those. There's also other repository hosting services like Bitbucket or GitLab. And we're going to focus on GitHub because it's the predominant service that people use, especially in academia. Okay, so getting started with Git. So hopefully everyone's downloaded Git at this point. You can follow the link here for instructions on how to get it downloaded. Once you have it downloaded, hopefully when you run the command git --version, it should give you some response back that looks like this. Now, one thing to be clear here is this is not in R. Okay, this will be on the command line. So if you're in a Windows machine, you'll have to open up the command prompt. And if you are on a Mac machine or a Linux, you'll have to open up the terminal. You can, in theory, do it through RStudio because Studio has a terminal option. So I can show you real quick that. So if you're getting familiar with this, right, you can just do it in here if you want. But so you'll just put it into your terminal. Oh, sorry, my sharing went a bit crazy there. Okay, so hopefully everyone has been able to access Git in this way, either through their command prompt or other ways through terminal. And so what you need to be able to do now is actually start working with Git. Okay, and so the way we do this is we just make a normal folder, just like you would do normally. And so the commands for doing this in command line are mkdir for make directory. So I'm making a directory called my project folder. And then I'm changing my position into that directory with my project folder. Okay, so I use cd and I change my directory. So this is the command line equivalence of setting the setwd, and this is an equivalent in R of dir.create. Okay, so I've made this folder and I want to have a project in it. And I want this to be tracked by GitHub, or Git even, sorry. I'm gonna try my best to say Git when I mean Git and GitHub when I mean GitHub, but even though I think about this all the time, I could still make faux pas. Okay, so what you'll do is you'll make this directory, you'll change your directory into this, and then you use the command git init. Okay, and what this does will initialize a GitHub repository. And this has gone back to front, but you should get back a response that looks like this: initialized empty Git repository. Okay, and so once you've initialized, it is now a Git repository. What does that mean? So you can have a look to see if you can see anything different about your repository. Okay, and so if you're doing it in the same place that I am, you'll see some other folders. Okay. To be able to see what's in a directory, you can use the commands ls. Okay, and then you can use it with ls dot, and that means I want to look in where I'm looking. And that's for Mac and Linux. For Windows, it's dir and dot. Okay, and then when you do this, you should be able to see all the files that are contained in this folder. Okay, so at that point, it should be empty. But there are some hidden files that have been created. And so you'll be able to see this if you use this command in Windows, dir./ah, that reveals the hidden folders, or ls -a, and then the full stop. And so this is an argument that you supply to ls that says, I want to see the hidden files. And you'll see a file in there that begins .git. We can have a look at what's in .git by specifying ls-a, and then we specify that we want to look at .git. And when we do that, it will specify that inside, what you'll see is all these different extra folders. Okay, so it says some information about branches, the config, description, head. And so this is what makes a Git repository a Git repository. It has all this information, and this is where it's going to be tracking everything. Okay, so we have a amichai dir cannot access AH, no such file or directory. Oh. Okay, so this isn't working. Okay, I tested this on my Windows machine and it should have worked, but I'm guessing it's not. Is other people? No. Okay, so you need to put a space in between the dot and the AH. So what the dot is doing is it's specifying, I want to look in the directory that I'm in, and then the space, and then the AH, and what the AH is doing is saying, oh, I am looking specifically for hidden files. So that's adding an option to dir. Okay. So hopefully the space helped. Okay, I can look into this. It doesn't matter too much. This is just kind of demoing what's inside the Git repository and what makes a Git repository special. And so essentially you have, it looks like a normal directory, but you have these hidden files called .git files that's saving all this information. And that's what makes it special. Okay. Otherwise, it just looks like it's empty. Okay, and so you can explore and have a play. And so then once you've initialized a folder, you'll actually want to make the Git to be yours. Okay, and so you do this by updating the configuration of your Git. And so this means that every time you're going to make an edit in the future, it will attribute it to your username. And in the future, also, when you want to push changes up to GitHub, it will know the email address that's associated with the Git. And so this will allow you to get user login credentials and things like that. And so to do this, you would do git config global, and then you write username, and then you add in your username. Okay, so here I have the username that I use in my GitHub, or the BRC GitHub. And so if you are unsure if you have a username associated, you can just type in this command and it'll tell you what is associated with your Git. And maybe you'll want to update it so you can then run the first command. Likewise, you can do exactly the same, but instead of doing user.name, you do user.email, and you add in the email, and you can check it with this. Okay, so if you add in this extra argument, it will assign that to this, but if you don't add it, it will just echo it back. Okay, so now we want to start actually using the Git repository that we've created. Okay, and so when I say repository, repository is just essentially a folder that has Git enabled within it. Okay, and so we have our folder, and what I can do is, this is a trick just to create a file. Okay, if I say touch and I say readme.md, it creates a folder, a file called readme.md. Okay, so by doing that, I've now created a file. But you can create a file more manually if you want by just opening up a R script and saving it to there, or whatever you want to do. And then you can always check what's happening with your Git by doing Git Status. Okay, so this is the whole point. We're now going to check the status of our Git. And it will tell you some stuff. So it's telling me I have no commits yet. I have a bunch of untracked files, okay? And included is that README I just added. And so what it means by untracked files is they're not in the history of this Git repository. So I have a Git repository that I created. I have a file, and it's being untracked because it hasn't been added to my Git. Okay, it knows it's there, and that's why it's appearing in the status. It just knows it's not being tracked by the history associated with Git. So we want to change that. And so we do that in using this workflow, and there's 3 stages associated with managing Git. You have number 1, you have your working directory. You make and save changes to files, and Git will be aware of it, but not necessarily involved at this step. So that's what I just did. I created a README markdown document. Anything that's new will be considered untracked. If you are just making amendments to a file, it will know that there have been changes, but it won't, they'll be tracked because it has history, but those changes won't be added to the Git yet. When you have these changes, you can do the next step, which is staging them. And so you add them to what's called the staged area. And still, staged files are not added to your Git repository, but they're ready to be, okay? And so you can do this with many files all at once, or just one file. And then once you finish your edits or whatever you're working on, you've added a chunk of work that you've done, and you've staged it all, you can then do what's called committing. And when you commit it, it is then added to your Git repository. The history is added to the history of the repository, and those changes are essentially committed. And so it only does this to the files that have been staged. So it's a two-step process. You can make all the changes you want, as long as if they don't get staged, they will not be committed. And so this seems kind of complicated, but there's a rationale behind it. The idea is that you may want to make changes to several files at once, and then you want to group them together and commit them together. So really, you're not it's not like saving as you go. The idea is you don't commit every time you add a new line of code or anything like that. Each commit itself should be a nice little story. So say I'm working on a piece of data analysis, or I'm working on a function in a pipeline, right? And while I'm developing it and testing it out, I'm saving locally. And then I think it's working. I made a significant upgrade. I finished the function. I'll then maybe update the README, which describes how you use the function. And then I'll stage them both together and commit them together and say, when I commit them, I have, in the message that you attach to the commit, you'll say, I've updated this function and it's README. And so the aim with this is to make a coherent commit that is really easy to understand. You don't want to be just grabbing loose ends here and there, because the idea is when you look back at this later on, you want to understand what you were doing. What was this individual commit for? And this also helps when you collaborate as well, because people will look back through your code and they'll be like, well, they did a change to these 3 files, but these 3 files do completely different things, so it makes no sense. But if you commit those things separately, because there were 3 different projects, 3 different edits or bugs that you were fixing, then that will make more sense. And so when you make these commits, as I've alluded to, you add a commit message to say what the purpose of the commit is. And so the good rule that you can associate with this is you shouldn't really have multiple clauses in your commit message, because that typically means you're doing multiple things. And so really, these messages are logs. Commits are logs of your progress and what you're doing and how the code is changing. And so having it's a good log of what you're doing is important, but it is a balance of not over committing, as in committing every single thing, but also not under committing. So you just have this massive chunk of work, like 2 weeks of work goes in at once. You want each step to be kind of deliberate and thoughtful and coherent and succinct. And when you do this, your future self will definitely thank you for making edits in this way. That said, it takes a while to get used to, and I still make really bad commits all the time just out of laziness. So I'm telling you, the idealized way of doing this, but it isn't always practical. And so John Nicholas had a question: everything you commit will be permanently viewable from anyone. To a certain extent, yes. So there are ways to erase history if you do want to erase something. And also, a Git doesn't have to be public. So when you're creating this, when you've initialized this Git that you have locally right now, no one else has access to it. If you share it with someone, they will be able to look back and they'll be able to see how it was built. Yeah, I wouldn't worry too much about that, because most of the time people know that something evolves from something that's a pretty janky and a bit all over the place into something that's much more refined. And if anything, if you're in the future looking at bioinformatics as a future career option, having a long history is also actually quite beneficial. Okay, so how does this work in practicality? Staging uses the Git Add command. So in this case, I want to add my README file. And so I just say Git Add README, and you specify the file that you want to add. And when we look at the Git status, you can see that there's still no commits yet. We have changes to be committed, and that's our new file, the readme.md, and we still have some untracked files. Okay, and so you can see how monitoring the status you can keep an eye on how your Git is progressing. And then you make the commit. So you say git commit, you add -m, and then you write your message in quotations. So in this, it's really simple. I just say I made a README. Okay. And then you can check your status again. And wait a sec. This right here, sorry, these should be separated. This right here is the response you'll get from the git commit. Okay, so it tells you you've changed one file. There's been 0 insertions, 0 deletions, and the commit has this ID associated with it. So this is the ID for the commit. So if you ever want to look at it in the future, you can go back to this ID. And then when we look at status, it looks like this. And there's no longer anything staged anymore. It's not telling us anymore that there's no commits have been made. It's just telling us what is different. So what are the untracked files? Okay, so you can always, while you're doing this, there's an extra tool that can help you keep an eye on what has changed. And that is Git Diff. So in this case, I'm going to change the README. And what this command is doing is it's adding a piece of text called hello friends into my README. So if I opened up my README, on the first line, it would say hello friends. Okay, that's what this is doing. It's saying echo, write this into my README file. Okay. Then if I look at Git status, it would say this has been modified. And then if I do Git Diff, it would actually tell me the difference between, it would show me the changes between these files. And so it's always good to check what's changing in your stage files before you commit. And so Git Diff allows you to do that. And so whenever I'm about to add something, so I added this, I check the status, it's all changes are ready to be committed. You can then check Git Diff and it'll tell you what the changes are. So this is an example here. I do Git Diff and I compare to this, you add the argument staged. So when you do Git Diff regularly, it will just change you what has changed in the background. But if you want to ask what's changed between the staged and your main branch, or basically what is saved in your Git repository, you can actually check that with Git Diff and then by adding the argument staged. And so when you do this, it will tell you hello friends has been added. So this is it. So there's been a subtraction and an addition to the README folder. And the addition is hello friends. And so this is a really simple example, but when you're adding lots of code, it will show you what the code you've added is, what files are changing. And so you can make sure that when you do a commit, you're not accidentally getting some extra things that you don't need. Okay, and then in this case, we're just going to commit this in again. I'm going to say we added a welcome message. Once you've made some changes, you can use Git Log, and this will tell you what changes have been made, and it will tell you about the commits. So here you'll see these are log IDs, or your commit IDs, and it will tell you who made the changes, when they were made, and what the name of the commit is, or the messages associated with it. And you can also modify this if you don't want to read everything about the log. This is a lot of different information. You can get specific things. So if you just want to get a one line for each commit, this is just a one line for each commit. Or if you want to get some more information about what files changed, you can use on one line stat. And it'll tell you the README changed. You can also use patch to actually see what the contents change as well. So, but I'm not going to show you that because it's really big. Okay, so that is kind of your basics of working with Git on the command line. Okay, you have your 3 steps. You stage. You make your changes locally. You stage them, and then you commit them. Okay, and that's really the big thing that you need to get your head around with working with commit. Okay, so the next step is to then connect whatever you're doing locally to GitHub. And so why would we do that? Well, like we're talking about, your Git is local. It's you on your computer. But 9 times out of 10, you want to be able to either show your data publicly and show your analysis publicly. Say you publish something. You want to be able to show that code, or you want to be able to share your code with collaborators. And those are the predominant ways. The other nice thing about when you push it up to GitHub is it's saved online, so you now have a backup of your code as well. And so it's a really nice way of having a collaboration, a backup, and shared all at once. And you can control whether a repository is public or private. When you create an account, I believe you might be limited in the number of private repositories you can have. But because we're an academic institute, you can get a free pro account. And then from that, you can have as many private repositories as you want. The other thing that's nice, well, specifically GitHub, I mentioned that there are other services that do this, like Bitbucket and things like that. The nice thing about GitHub is you can get it direct access through the web, right? So there's a nice interface that we're going to get used to, right? So this is my GitHub. And so you can start to interact with it like this. A lot of alternatives don't have that, and they might have a desktop tool to interact with it, but it's not as streamlined. There is something called issues and pulling pull requests, which we'll get into in a little bit as examples of good workflow, but they're really important factors. GitHub also has, because it's used so much, it has the most support in the community. It also has, one of the reasons it is used so much, it has a hugely extensive features, such as automated systems that we use a lot. So the courses are automatically compiled using a system that we've built on GitHub. So we push up whenever I make a change to the course, we push it up to GitHub, and then it will automatically rebuild everything and correct any of the changes we made. It also supports a lot of different file formats, and then they have a community aspect, so you can actually see what things are happening. So if I click on my home, oh, I'm not signed in. Okay, I'm not going to sign in because I might give away my password, but there's a home, you have a home hub, and you get to follow different people that you're interested in, how they're coding. You get to see how their projects are changing for whatever repositories they have public. And so it's actually a really useful way of keeping on top of, say, you're interested in mapping algorithms. If you follow the people that develop those mapping algorithms, you can see the changes they're making and keep up to date with that progress. One of the big drawbacks of GitHub, though, it is essentially a monopoly because most people use it. And so this has led to problems even like a couple of years ago. All Iranian people on GitHub were kicked off and lost access to their repositories because of the embargoes that the US brought in. So when you're trying to develop an open source and very friendly community online, that is a problem. Okay, so I always get touch is not recognized as an internal or external command. Okay, are you working on a Windows machine? Because I think some of these issues are with Windows, and I did try out all the code on Windows, and it did work on Windows for me, but I'm guessing I need to double check some of these things. But all the Git commands should still work, I'm hoping. Okay, so touch is just my I had problems and changed all the so it might be a question of the commas, not the commas, the quotations. Quotations can sometimes be an issue with systems, so I might have to change my quotations. But yeah, all I'm doing with touch is just creating a file in a quick and easy way, and then in a way that's automated by our system. But you can just create a file however you want, and then you can try and just create and save that file into your repository. And then you can try and commit it or edit it and however you want. Well, you'll first want to add it to stage it, and then you'll want to commit it. Okay, so so as we said, everything is local, and so really to be able to do this, you're going to have to sign up to GitHub. So hopefully everyone had a chance to do that ahead of time. If not, you can sign up now. But you can just go to the GitHub website and sign up. They just need an email. I'd recommend associating your academic email with it, because that's what you can then use to get the pro account. You can then also add a secondary email, which could be your personal email, so that if and when you do leave Rockefeller, it will stay with you. Okay, so when we could do this, I can show you directly on GitHub now. Okay, so I just opened up GitHub. Okay, and so this is my GitHub homepage. And so it might look a little bit different because I have dark mode on. But this is me. And what you'll want to be able to do is create a repository. So I can say I want to create a new repository. If you have a template, you could use a template. I have some templates. Or you can give it a name. Okay, so in this example, I'm just using test. I already have that because I've used tests. And my GitHub test. You can add a description. You can decide whether it's public or private here. There's some other options here. READMEs are nice to add because they add a description of the repository. Git ignores we'll explain in a little bit, but maybe we'll make this private. And so you just create the repository. And you see here, now we have a repository. And so in this, we have one folder or one file, and this is the README. And then you have all these other things associated with it. But really, all that matters is this code. Okay, and so once you've created a repository, you then want to be able to link it to your local. So you can do that by doing this. We go code and we do copy. Okay. And so once you've copied it, like we just did, you can then add a remote to your local Git. Okay, so this is basically you're telling your folder, you're telling your repository, where can I point to remotely, and you give it the address. Okay, and so you're saying git remote add. I want to add a remote, and it's called origin. So typically people call the main remote that they're using, which in this case is your GitHub repository, then most of the people call it origin. That's just kind of standard that you'll see. But all it is the name. And then we tell it where it is. Okay. And then once you've done that, what you can do is your local is now connected to your distant on GitHub. And so any of the things that you have locally can be pushed up to GitHub. So in this case, we had a README that we created locally. And we can say git push -u origin master. You can also do it without the -u, it should still work. And what that will do is anything you've done locally will be pushed up to GitHub. So this is like if you ever use syncing or anything like that with the cloud, this is almost like doing that, but it's a very manual way of doing it. Broadly, you want to do edits through Git and you'll want to do it locally. Okay, but you can make commits on GitHub itself. So I can quickly show you that. So I could open up this here and I can edit it. And just add it hi. And so you can make a change here. And so this is my message, and I'm committing it direct to the new branch, to the main branch. Okay, and now it's added. And now this is part of my commit history. So you can see my commit history here. Okay. But I'd say generally, this is not the best practice because normally you don't want to edit one file at once. This is it's a very like GUI way of doing it. And generally you want to be able to work locally. Okay, whenever your local Git is behind a remote Git, you can do the opposite of pull, which is push. So that if you say make a change remotely, or if your collaborator makes a change to your shared repository, so you can make the repository shared, then you can use git pull to update your local one. Okay. So now we're going to talk about GUIs, okay? So I showed you how to do these things on the command line. And these are really important to understand the rationale behind the commands. And quite often you'll have to get your hands a little dirty from time to time just by doing this. But most of the time when I'm interacting with Git, it's through RStudio, okay? And there is another alternative, which I know some of you have downloaded, which is Github Desktop, okay? And both of these are really good tools for working with Git in a way that probably is going to be your easiest doorway into this. Okay, and so both of these tools essentially under the hood are using the same Git commands that I showed you how to use, but they'll just add a point and click interface to them. Okay, so if I have GitHub Desktop here. Okay, and so this is my GitHub Desktop, and it's really easy to add new things. So I can go to here, I could add, I could clone a repository directly from GitHub. I can add a new existing repository from my local machine. Okay, so I just pick where it comes from. And then once I've added it, that repository will then be available to me. And you'll be able to pick between your options. So I have a couple on my GitHub here. And then you can access some of the things that we've talked about, right? So if a change is made, it will appear here. Okay, and then once you have several changes, you can stage them and commit them by highlighting them. Okay, so you can see the history of the changes I've made here. And if I switch you back to this, if I do make a change, like here I made a change to my README, I can just click on this tick box, then add a commit message and commit it in a very like point and click way. And then when I want to push it up to GitHub, I can just press push. And likewise, when it's behind, I can press pull and it will just appear on the home screen of the repository. And so if you want to use GitHub Desktop, there's help setting up here and help using the software here. Okay, there's some nice links for using GitHub Desktop. Okay, so the way I'd imagine this working is you work in RStudio, you have your analysis. Once you finish a section, you can then go across to your GitHub Desktop and you'd update, make some commits into Git based on the changes you've made. Now with RStudio, Git is integrated through its project management system. So we haven't really talked too much about projects, but R has this project management system where it will create a new folder and every piece of analysis that you're working on can be saved in that folder. And that folder is considered to be a project. When you start these new projects, you can create them in a version controlled way. And so this gives you options for different kinds of version control. But you can see the steps to set it up here. It's just file, new project, and then you click version control. And so they have an SVN option, which is one of the main other version control system that people use. But we can click Git. And so then it wants you to clone a Git repository at this point. So what we mean by clone is it's expecting you to have an address of somewhere, like from GitHub. So if we saw earlier, I can just show you locally. Okay, so we have this. If I go new, no, it's this one. Oh, wrong one. It's this one right here. Let's not save. I'll get new. Can you see the new project wizard that just popped up? Cool. So I can click version control, I can click Git. And so I think I still have this saved in here. Yeah. So I put in the address that I got from GitHub when I created a repository. I give it my name. It will automatically fill it in with the name of the repository, but you can change it to whatever you want it to be. And then you can have a quick browse and you can put this wherever you want it to be. Okay, I'm not going to create this project for real, but you could in theory put this, you could put this on your desktop, you can put it wherever you save your analyses. Okay, so you're not going to just have one Git repository for all of your work. You'll have a Git repository for every subset of analysis that you do, or every project that you do. That's the best way to do it. Okay, and so once you've done this, you get your address like we just did, and now you have your Git available to you. Okay, and so once this is set up, you can then look here, and there's a Git tab up here on the top right. Okay, and so once you have this Git tab open, it shows you the status automatically. So like this file was modified, this file was deleted. You can see all these new files that are untracked, so it has a question mark. These were the ones I created during the R Markdown session. And so if you want to stage them, it's as simple as doing that. Okay. Then you can press commit. Okay, and I don't think you can see this, so I'm gonna just switch. So when you do this, you get this pop-up, and then you have several options. So I can unstage them again. It will show down here the differences. So here is the difference. It's all green because I all just created this, but maybe here I deleted something here. And then you can just put in a commit message and commit it with the button. And then once you've done with a bunch of commits, or after each commit, you can then push it up to your remote whenever you want it to be pushed up to GitHub. And it will be associated with the repository that you pulled it from. Okay. So this works in pretty much the same way as GitHub Desktop. The reason I like it is it just means I have one program open up at once. GitHub Desktop has benefits in the fact that it is directly integrated into GitHub. So you can don't have to go through as many steps to set something up because it is connected to your GitHub. It knows what repositories you have online. And so you can just point and click for the ones you want without having to copy and paste addresses and things like that. Okay, so this final section, we might run like 10 minutes over, I think, because I don't think I'll get through this in 5 minutes. But I wanted to just provide an overview of how a good workflow might work and introduce you into a couple of other ideas that we haven't yet touched on with Git. Okay, so when you're collaborating with Git, or if you're working with solo, there is a kind of a best practice of the way to do things. So the first step would be to raise an issue on GitHub, okay? And so we showed you how to raise issues at the beginning of the course. This is what we encourage people to do if they ever have a problem with the course, have questions, but it's not during a session, okay? We can then, because we manage the repositories, we'll get an alert to say there's a problem with it, and we can look at your question and say, oh, I can do this to fix it. Or I can answer your question directly in the issue thread, okay? You would then, once you've realized there's a problem or there's something you want to add, something like that, you then can create a branch to address that issue. So this means you keep your main repository intact and you create a separate branch, which you're going to go off and play around with some things and see if you can add something or fix something. Oh, thanks, Adam. I'll see you next week. Okay, then once you've created the branch, you'll then do some commits to produce some updates and gradually work through the process of fixing whatever issue you have or making the updates you want to make. You'll then do something which is called a pull request, which is you basically ask permission of the repository to pull these changes on your branch into the main, the master branch, okay? You can review the changes. You'll get some feedback from whoever's in charge of the repository. Maybe that's you. It'll give you a chance to review the code, and then you can merge the changes in. Okay, and so some of these things you may be unfamiliar with because we haven't covered them yet. And so I'll go through each step in process. So first, raising an issue. This can be done by anyone. Any repository that is public can have an issue raised on it. So if you're using a tool, a package in R, and there's a feature you want to be added, 9 times out of 10, they'll have a GitHub. You'll be able to go and find the GitHub and say, I really like your statistical tool. I know you use Bonferroni for the correction for multiple testing. Could you also add Benjamini Hochberg, right? And you could raise that issue with them, okay? That issue will then raise an alert with them. They'll probably get an email notification, and they can choose if they want to actually update the fixes. It could be for anything like that, or it could just be for simple typo in your documentation. And so I'm talking about this often with regards to like pipelines or packages, but I use this system for my own analysis. So I know that I talk to someone and I need to add this to a project I'm working on. So I'll raise an issue on GitHub, and then I have a track record of what I'm working on and what needs to be done. Okay, and so you can add it, you do it by, you go to new issue, you can have a header, and then you describe what you need to be done. Next, you'd create a branch. And so anytime you're making modification to a repository that's actively in use, that can be dangerous because you could then change how it's working for someone else. Or if it's a piece of code that you're using regularly, if you need to change it for one project and then you break it, but then you need it for another project, that can also be bad. So by creating a branch, you have a static working version that you're happy with, and then you can make updates to the branch and then eventually bring those updates back in. And so commonly used for building a new feature or fixing a bug. And so when you create a branch, it basically creates a duplicate. It has the same history. It's just a divergence. And so this is always important to remember that the master should reflect what is published. It should reflect what you want public, or it should reflect what you consider to be the most stable version of the code. And any branch off of the master can be something new or exciting or a development. And so there's a couple ways to do this. You can do it on the command line if you want to create a new branch. You do git branch, and then you have the name of the branch. Okay, or in RStudio, this is the branching icon, and you can create a new branch this way. When you create a new branch on the remote, on the command line, you can check what branches are available by just saying git branch. And you'll notice there's a little asterisk by master. What this means is this is the active branch that I'm on. So to switch branches, you have to use a command called checkout. So once you've created the branch, you'll use git checkout, and this means I want to now work on the new branch. So I do git checkout and I put new branch, and then it tells you I've now switched over to the new branch. And if you check git branch, the asterisk is now by new branch. Okay, and so this means you can switch between the two depending on what you're working on and what you're using. When you're doing it in RStudio, if you click the branching icon, you'll be able to see both branches. Okay, and you can just click on them and that will switch it for you. And you'll see whichever is active here. That will tell you which is the active branch at the moment. Most of the time when you use checkout, you'll be using it to move between branches, but you can also use it to move backwards and forwards in time by checking out specific commits. So if you look at your history, there will be this track name of IDs, commit IDs. And so if you ever do git checkout commit ID, you can go back in time and look at the state of the repository at that commit. So sometimes that's useful if you make a bunch of edits and actually you can't figure out where it all went wrong. And so maybe you want to check out and go back to the beginning, see where it was working fine, figure out where it breaks, and then you'll eventually remove those commits. You can also use checkout to actually remove some commits that haven't been staged as well. But you use that with git checkout, and then you put the file name. And so what this does is it rolls it back to the version of the file that's saved in the repository, in the history. Okay, so we have a question from Cart. Can you have both the master branches up on GitHub in the repository, or are the branches only local? No, so all the branches when you push will be synced up. You can specify which branches if you want, or if you don't specify, it will do both. So you can actually see here in RStudio, you can actually access the local branches and the remote versions of these branches through this drop-down menu here. So this is another nice way that RStudio helps, is you can switch between all these different versions of the branches. Okay, and so that's actually an important step in what happens next. Because once you've made the branch, you need to then integrate it back into the master. And so there is a function called merge that Git uses that allows you to merge things back in. But generally, I recommend you actually use a pull request. So a pull request is the GitHub equivalent. And they're really one of the cornerstones of collaborative working in GitHub. Okay, so the way they work is when you make a change on a branch, it gives you an option to compare and pull request. Okay, and you can also, this is in the tab called pull requests. Okay, so yeah. And so once you've have these two branches and you make a change and you want to bring this branch back in, you can start this thing called a pull request. And what it does is it first will check, can I bring the new branch back into the master? And it does this in a nice and interactive way, so it's very easy to see. And what I mean by can it be brought back in is, are there any conflicts? Sometimes what you'll find is someone has edited the master and you've also edited the branch. And then when you try and bring them back together, you've edited the same line, and then it doesn't know which one to take. So it just double checks to make sure that's not the case. Here we are. And what it will do is below this, it will display the files that have changed. Okay, so you can see what's in your pull request. And then when you create the pull request, or you open it up, you add some text. Okay, this is very similar to when you create the issue in the first place, but this is the resolution of the issue. And so what you can say is, I've added this file, I've fixed this bug, I've addressed this in this way. And what you can do when you do this is you can actually assign people to this review. So if you are not the person that owns this repository, you can basically get someone else to review the code to make sure it's okay to be brought back in. Similarly, if you don't have permission, if you don't have the authority to bring it in as well, you will have to wait for someone else to approve your code changes. And so once the pull request is added, it is not integrated yet. It's basically up for review. And so this means anyone can add comments to this pull request. And it becomes a dialogue between the people developing and working on the repository. Or it could be a conversation with yourself about what you're doing and what the next steps are, or if there's something you realize that you need to change. And so this is all saved on GitHub. And so it's the nice thing about GitHub is then it preserves this kind of community of what the changes are, what makes sense, and you have this kind of culture around the repository. And then once everyone is happy, you merge the pull request, and you'll get an option to delete the old branch. Okay, and 9 times out of 10, you want to delete that old branch because it's not doing anything useful anymore. So as I was mentioning before, you have pull requests and you have git merge. Git merge, if you're working just by yourself and you're working locally, git merge works just fine. But doing the whole pull request workflow is good practice. It adds more steps for review to make sure that you're not doing anything wrong. And it is a nicer interface to work with than working on the command line. Another thing is it is just generally good practice, because there will be times if you get into coding where you will be working collaboratively with people, and this is the main method that people do this. Okay, and so as I mentioned earlier, occasionally you'll get a conflict. And so when you have a pull or a merge, a conflict can come about if the same line has been edited, but you're not sure which one should take precedent. And so you'll get an error message, and it'll say merge error, conflict found. And so the way you do that is, the way you fix it is you go to the files that have the conflict. And so it will tell you which files have the conflict. You'll have to open the files up, and you'll find a piece of code that looks something like this, okay? And so there'll be this delineation that says head with a bunch of less than signs. There'll be some piece of code here. Then there'll be a bunch of equal signs. There'll be a second piece of code, and then there'll be a bunch of greater than signs followed by the branch name, okay? And so what this means is this is code that's found in the master, and this is code that's found in your branch. And it thinks these codes are it knows these codes correspond to the same place in the file. And you just have to choose which one you want to be found in the master after the merge. And so you have a look at them, decide which one is the one you actually want, and then you delete everything. So you delete this. Say I wanted to keep the master code. I delete this, and I delete this. And then you just leave the master code behind, and then you would have fixed the conflict. If you find it on while working the pull request, it actually walks you through it in a step-by-step manner. So this is another reason why the pull request is really nice, because you can do it all through GitHub. If you're doing it locally, then you're going to have to go into the files themselves, figure out which ones they are, and then find it. And they won't be highlighted in green or anything like that for you. Okay, and so I'll just quickly finish up with some other useful Git and GitHub commands and utilities. How do I work on a project that belongs to someone else on GitHub? So any public repository, you can do something that's called a fork from, okay? And that means you create a whole new copy of that repository in your GitHub. And so you don't even need to know them. You don't need to have permission. But it's a nice way of being able to see what people's code is, start to play around with it, adapt it to what you maybe want to do. Alternatively, if you see someone has a package and there's a bug in it and you've figured out how to fix it, you could take a fork and fix the bug and then create a pull request to push it back into the original repository. So it's like the GitHub equivalent of branching, but it has the added layer of giving you permission to start to play around with some code that you maybe don't have permission to manipulate on the actual original repository. And so this is pretty much what I just said. You can adapt it to your needs. If you want to build things like websites and stuff like that, you can borrow someone else's website template and do it that way. And the big thing that you'd have to check if you want to redeploy any of the code yourself is just if it has a license and what that license means. But the main way I use it is when I'm collaborating, I might take a fork of someone else's repository, I might do some work on there, and then I'll push it back to them afterwards with a pull request. Another nice thing to know is sometimes you don't want large files or private files to be uploaded to GitHub. And so you can add a file called a .git ignore in your Git directory locally, and it will prevent anything that's in the .git ignore being synced to your remote. So quite often what I'm using this for is if I have BAMs or bigwigs locally because they're so large, I don't want them to go up to GitHub. So it will take a very long time, and B, there are size limits on what GitHub will allow you to put up there. Plus also some of the, if you have a public repository, you don't want some of the kind of private analysis that you're doing to be put up there. So you can add them to your just .git ignore. And so this is just a plain file. You can create it yourself. You just have to call it .git ignore. And so here is an example of one, and it has a bunch of our user information. Okay. And it accepts wildcards. So quite often you're just trying to obscure a specific file type. So you just use the wildcard and then the extension. When you move files on GitHub, it can get confused, and it treats it like you've deleted a file and then created a new file. And so this is an issue if you want to track the history, right? Because when you delete a file, that history is gone and it's not associated with the new file. So if you do that on the command line, it struggles. But if you do it through the Git interface on RStudio, it figures it out, as long as you stage the deletion and creation at the same time. But if you want to be able to do it manually, there is a git move command. Okay, and there is also similarly on the command line, you can also git add everything at once and use the -a, and it will also help stitch together those deletions and additions. Okay, whenever you do git add, if you do a full stop, it will stage everything that's changed. So that's a useful shortcut. Okay, and so the last ones are RM, that's to remove files. But there's a bunch of parameters if you just want to stop it from being tracked, and so it's not deleted locally, or if you want to delete its entire history. Rebase, it's an alternative to merge, and this is really useful when you have a master that has updates, and you have a branch and you want to update your branch to be equivalent with the master. Maybe you're not ready to put your branch's changes back into the master, but you want to include the master's changes in your branch. Now, that can be a bit confusing, but Rebase is a useful tool for that. And Reset is a really useful tool for resetting and rewinding back stages and commits. Okay, but for more like in-depth, you can always look at the Git Book. It's really, really well written and very exhaustive resource for all your Git needs. Okay. Some extra resources. The Git School have a nice tool to help you understand branching. Okay, I can quickly show you this. And so as you do things like git branch my branch, and then you can say git commit. Anyway, you can just use all the commands that you would normally use, and it will show you where you are. And what the topology looks like. No, I deleted that by accident. Okay, so you can see the master is here, and I just added a commit. But I could then go back and check out master again. So I move back to the master, and I can make another branch. Okay. So you can play around with this and start to get an idea of how this works in a very visual way. I know I find it helpful because I'm a more visual learner. There is a GitHub help page, which can be very useful. And then I think the big thing that is really tough to get down is the collaborative side of GitHub. It can be very tough to do. I think early on, Jean Nicholas, I think it was expressing his concern with everyone being able to see his past commits. And so a way to get around this is to play around with GitHub, but in a low stakes arenas, essentially. And so there's plenty of plenty of repositories that people have created, which are more looking at the lighter side of life. And so an example is here, where there's just a series of dad jokes. And the idea is you can submit your own by creating an issue or taking a fork, then doing a pull request. And if it makes him laugh, he'll add it in. Okay. And so we have a similar setup in the exercises, in which we have our own repository, which you can add to and play around with and try and go through the steps in the workflow to learn how to do this before you're doing it for real, while you're collaborating with someone that it matters what it looks like. Okay. And then the final part is Git and GitHub and R. There are also packages specifically designed to be used with Git and GitHub in R. And so if you want to do everything through R, you can. And there's the packages Git2R and Git, which work with Git. And then there's GH, which interacts with GitHub. And so this means you can just use the R packages if you prefer it that way. Okay, so like I said, this is the first time we're running through this. Obviously, we overran, so I underestimated the time I needed. But if anyone has any suggestions or edits or things that they think were too confusing, or slide layouts, anything like that, feel free to let me know. That would be super useful. And thank you to everyone who stuck it to the end. I know it was a long 3 days. Hopefully, I will see a bunch of you next week for Bioconductor. And so that Bioconductor is really going to build on the skills you've learned with R and actually start to apply it to some data that you'll recognize. Oh, great. Good. I'm glad you are, John Nicholas. Okay. But yeah, and then if anyone has any problems, you can always go to our GitHub and raise an issue. So let me just okay. If we go to Rockefeller University, this is where we are now. You'll be able to go into the issues page and raise an issue here.